this is Ramats and it's me, Priska Joseph. So now, PYQ 2019. Before discussing the questions, if you're watching my channel, please subscribe it. And don't forget to hit the bell icon for the notifications. Your doubts, queries, everything will be commented below. Okay? So let's start. So the first question is, the HCF of two numbers A and B is 5 and their LCM is 200. Find the product of AB. Once again, the HCF of two numbers A and B is 5 and their LCM is 200. Find the product of AB. So this is the question. Actually, this is very simple. We already studied an equation, that is product of HCF and LCM is equal to product of two numbers. Okay, so what is HCF? In this case, HCF is 5 and LCM is 200. Okay, so let's substitute. HCF is 5 and LCM is 200 and the product of two numbers is equal to A into B. Okay, so 5 times 200 is 1000. Okay, which is equal to product of two numbers AB. So we have to find the product of AB and it is 1000. Okay, actually this is very simple. You have to study this equation by heart. Okay, so this is the answer. Let's solve the next question. And the second question is, if HCF of 65 and 170 is expressible in the form 65 and minus 170, then find the value of n. Okay, once again, if HCF of 65 and 117 is expressible in the form of 65 and minus 117, then find the value of n. So this is the question. So there is an expression for HCF. So first we have to find out HCF of two numbers 65 and 170. So what is 65? We have to factorize 65 like this. That is 5 is the 1 5 is 5, 30. Okay, so 5 into 30, both are prime numbers, and 170. Okay, 117. So 3 is the 3 3s are 9, 2 is the 9 3s are 27. Again 3, 1 3 is 3, 3 3s are 19. Okay, so factors are 3 to the power 2 into 30. Okay, so now what is HCF? HCF is the product of common factors with the least power. Okay, so 30. 13 should be taken as the HCF of these two numbers. So HCF is 30. Now there is an expression for HCF which is 65 and minus 117 which is equal to 30. Okay, so this is the expression for HCF. So we can equate this expression with the HCF. Okay, so 65n is equal to 13 plus 117. So what is it? 13, that is 10 is the 3 is the 1 is the, that is 130. So n is equal to 130 upon 65. So what is it? It is clearly 2. Okay, value of n in this expression is 2. Okay, so this is the answer. Hope it is clear for you. If you have any doubt, please ask me in the comment section. Okay, so let's move on to the next question. Now, the third question is, find the HCF of 612 and 1314 using prime factorization. Find the HCF of 612 and 1340 using prime factorization method. Okay, so let's factorize 612. Okay, so let's start with 2. So 2 is the 3 2s are 6, 0, 6 2s are 12. Okay, again with 2, 1 2 is 2, 5 2s are 10, 3 2s are 6. Okay, now 3 is the 5 3s are 15 and 1 3 is 3. Okay. Now again divide with 3. 1 3 is 3, 2 is the 7 3s are 21. Okay. So 612 is equal to 2 to the power 2 into 3 to the power 2 into 17. We cannot factorize 17 because it's a prime number. Okay, so these are the factors of 612. And now let's factorize 1340. Okay, 1340. So let's start with 2. 6 2s are 12. 1 is the 5 2s are 10. 7 2s are 14. Again divide with 3. 2 3s are 6. 1 3 is 3. 27. 9 3s are 27. Okay. Now 3 is the 7 3s are 21. 3 3s are 9. Okay. And finally we get 73 and it's clearly a prime number, so we can't factorize 73. Okay. So the factors of 1314 is equal to 2 into 3 to the power 2 into 73. Okay. So these are the factors of 612 and also 1340. And now we have to find out HCF. Okay, so what is HCF? So HCF is the product of common factors with least power. Okay, so here the common factors are 2 square and 2 is there. So we can select 2 into 3 square and 3 square. So we take 3 square. And here it is 17 and 73. So there is no other common factors. So 2 into 3 square is 9. So 9 times 2 is 18. Okay. So 18 is the HCF of the two numbers. Okay. Hope it is clear for you. Actually this is very simple. You have to learn how to factorize the numbers and the relation between the factors and HCF LCM. Okay, so this is the answer. So let's move on to the next question. So dear children, fourth question is, prove that root 5 is an irrational. Root 5 is an irrational. So we have to prove this statement. I am already explained here, so you have to listen carefully. The first step is assume root 5 is a rational number. Okay, the first assumption is root 5 is a rational number. We have to take a controversy statement, that is root 5 is a rational number, and we know that a rational number is a number which can be represented in the form of p by q, where q not equal to 0. Here in this case, root 5 can be equated with a and b, where a and b are co-primes. That is, root 5 is equal to a upon b, and a and b are co-prime numbers. Okay. On squaring both sides, we get 5 is equal to a square upon b square. Okay. On cross multiplication, a square is equal to 5b square. Then by theorem 1, if 5 divides a square, then 5 divides a. Okay, by using theorem 1, 5 divides a square, then 5 divides a. Okay, so now we introduce another term c, which is an integer, that is a is equal to 5c. Okay, hope it clear up to this. Okay, a is equal to 5c. So now substitute the value of a in equation 1. What happened? 5b square is equal to 25c square. We get 5b square is equal to 25c square. Then b square is equal to 5c square. And this is equation number 2. And now by theorem 1, what happened? If 5 divides b square, then 5 divides b. Okay, by using theorem 1, if 5 divides b square, then 5 divides b. And from both this relation, it is clear that 5 divides with both a and b. Okay, and from these two relationship, it's clear that 5 divides both a and b, and thus we can conclude that a and b are not co-primes. Okay, so a and b are not co-primes, so our supposition is wrong. Okay, what's that? We assumed that root 5 is a rational, and from these two relations, it's clear that a and b are co-primes, so our assumption was wrong. And finally, we can conclude that root 5 is a irrational number. Okay, hope it is clear for you. So you have to study this very well, because this is a short question for your board exam. Okay, start our next question. Now, the fifth question is, prove that 2 plus 5 root 3 is an irrational number. Okay, so as usual, we have to take a contradiction statement that 2 plus 5 root 3 is a rational number. Okay, and we know that a rational number which can be also represented in the form of p by q or a by q, whatever it is. So 2 plus 5 root 3 is equal to a upon b, where a and b are co-primes, and 5 root 3 is equal to a by b minus 2. That is, we have to rearrange this equation, and finally we get root 3 is equal to a by b minus 2 whole divided by 5. Okay, and we know that root 3 is a rational number, and a and b are integers. Okay, so this a and b are integers, not co-primes. So this statement, that is a and b are co-primes, so which contradicts the statement that contradicts the fact that root 3 is an irrational number. Okay, our assumption is wrong. 3 is a rational number and a and b are integers. Okay, so 1 by 5 into a by b, that is on rearranging this RHS, 1 by 5 into a by b minus 2 is a rational number. Okay, but this contradicts the fact that root 3 is an irrational number. Okay, this a by b is not a comma b are not co-primes. Okay, that was wrong. Okay, so this contradicts the fact that root 3 is an irrational number and our assumption is wrong. Okay, thus 2 plus 5 root 3 is an irrational number. Okay, so we proved this statement. Okay, hope it is clear for you. If you have any doubt, please ask me in the comment section. And this is a very important question. And let's move on to the final and last question from this 2019 PYQs. Okay. Now, the last question from the year 2019 is, write the smallest number which is divisible by both 306 and 657. Write the smallest number which is divisible by both 306 and 657. Dear children, in such a question we have to find out the LCM, and the LCM will be the smallest number which is divisible by both of the given numbers. Okay, so we have to find out LCM. Before that, we have to factorize these numbers. Okay, so first one is 306. How can we factorize? Let's start with 2. 1 2 is 2, and 5 is there. 5 2s are 10. 3 2s are 6. Now 3 is there. 5 3s are 15. 1 3 is 3. Again 3 is there. 1 3 is 3. 21. 7 3s are 21. Okay, so factors of 306 is equal to 2 into 3 to the power 2 into 17. 17 is a prime number, so we can factorize this number. Okay, and next number is 657. Now, so let's start with 3. 2 times 3 is 6. 1 3 is 3. 27. 9 3s are 27. Again 3 is the 7 3s are 21. 3 3s are 9. Okay, 73 is also a prime number, so we can factorize it. So the factors of 657 is equal to 3 to the power 2 into 73. Okay, so let's find out LCM. What is LCM? LCM is with highest powers. Okay, so here 2 is there. So 2 into 3 square into 73 into 17. Okay, so I'm not multiplying here. All these numbers we get the LCM. Okay, so I'm not writing the step by step. You have to solve each and every step. Okay, so the final answer will be 2338. Okay, so this will be the answer, LCM. You should practice this question. Okay, so this is the answer. Hope it is clear for you. If you have any doubt, please ask me in the comment section. So dear children, we complete chapter 1 and all the PYQs here. Okay, so at least you should know how to solve these PYQs. Okay, so that's all for the day. Thank you. Have a nice day.